Good morning. Today we will discuss the intensity of electric field placed at any point on the axis of an electric dipole. Make a dipole A minus Q charge on the point A and plus Q charge on the point B. The length of dipole we consider 2L, the length of electric dipole every time. Make sure that we every time consider the length of dipole, that is 2L. So the middle point O, the distance of middle point O to any side B or A would be L. Length of the middle point of electric dipole to a charge will be L. Make sure that every time we will consider the length of electric dipole, that is 2L. Now at a point on the axis of dipole, at a point P, the length we will consider the length of middle point of dipole to a point P, that is R. Now look the diagram. The distance between point B to P, that will be R minus L, and the length of from point A to point P, that will be R plus L. Now we know that the electric field due to charge Q at point P will be E is equal to 1 upon 4 pi epsilon 0 K plus Q upon distance from B to P, square of distance from B point to P point, that is R minus L square. Consider this intensity E1, electric field intensity E1. Now we can write here due to charge plus Q. Now same due to charge minus Q, the intensity of electric field E2 is equal to 1 upon 4 pi epsilon 0 K minus Q charge upon R plus L square. Now resultant electric field intensity. Resultant intensity will be E is equal to E1 plus E2. Okay, put the value of E1 and E2 from equation 1 and 2. We get 1 upon 4 pi epsilon 0 K Q upon minus L square. Here is plus, here is minus, so plus minus minus 1 upon 4 pi epsilon 0 k q upon whole square of r plus l. In the both term, take common from the both term, we get q upon 4 pi epsilon 0 k bracket 1 upon r minus l square minus 1 upon r plus l whole square. Now look, I have a trick to solve for this. In the proper manner, the calculation will be more than double time. So remember my trick. We will solve like this: q upon 4 pi epsilon 0 k. Here is a two quantity r and l. Okay, put here r and l, and look here. Here is a key point 4. Right here 4, and look, in one bracket r minus l, in one bracket r plus l. So r square minus l square whole square. Okay, now say that value of r square is greater than l square. Then we can say the value of l square can be neglect. Can be neglect. That means put the value of l square is equal to 0. We get A is equal to q upon 4 pi epsilon 0 k 4 rl upon r square minus 0 A is equal to q upon 4 pi epsilon 0 k 4 rl upon r 2 to the 4. Q upon 4 pi epsilon 0 k 4 rl upon r to the power 4 can be written as rq into r. Cancel r. We get E is equal to q 4l upon 4 pi epsilon 0 k rq. Look, the length of electric dipole, that is 2l, right here, q2. 4 can be written as 2l into 2, multiply 4 pi epsilon 0 k rq. Now rearrange this. 4 can be written as 2 into 2 l into q upon 4 pi epsilon 0 k r q is equal to 2p. The value of 2l into q will be p. 2p upon 4 pi epsilon 0 k r q, where p is equal to length of the electric dipole into one charge, because it is a electric dipole torque. Now we get E is equal to 1 upon 4 pi epsilon 0 k into 2p upon r q Newton per Coulomb Nc. Hence, this is our desired derivation. Okay.